Today we are going to see an important topic called Kirchhoff circuit law. Kirchhoff circuit law, it was proposed by the step Krichhoff. It deals with the two quantities, namely current and voltage. For current, he proposed a theory called Kirchhoff current law. For voltage, he proposed a theory called Kirchhoff voltage law. They are commonly known as KCL and KVL. Before we get into the definition, let's consider the following circuit. The circuit consists of 5.5 volt battery connecting to the motor. In between there is some resistors. The question raised to the engineer is to find the current flowing through the motor and the voltage difference across this motor. How should you find? If there is no resistor in between them, then the voltage across the motor is 5.5 volt and current across the motor is equal to V by R. That means 5.5 volt divided by the resistance of the motor. If we know the resistance of the motor, then we can easily find the current flowing through the motor. But here the case is it containing some resistors. Then how should you find? For this, KCL and KVL helps. Here's the definition of KCL. The total current or charge entering through a junction or node is exactly equal to the charge or current leaving the node or junction. If you feel confusing, don't worry. Consider the following circuit. We know current always flows from positive terminal of the battery to the negative terminal of the battery. Consider current flowing through this 10 ohm resistor is I1. Current flowing through this 10 ohm resistor is I2. Current flowing this 220 ohm series resistor is I3. We all know current flowing through the series components are same. Consider a node. Now you may have a doubt, what is node? Node is a form where two or more than two components are connected. We can also name a node as A. Now match this circuit with this law. Consider this node. This I1 is entering the node. This I2 is leaving the node. This I3 is also leaving the node. Okay? Now write the equation. Now we can write the equation from this diagram. Here I1 is the current or charge entering through the node. And here the definition is the current or charge entering a junction or node is at equal, right, I1 is equal to the charge or current leaving the node or junction. Here in this case I2 and I3 are the current that leaving this node. So write I2 plus I3. So write I2 plus I3. Here's the KCL equation. Here's the definition of Kirchhoff voltage law. Kirchhoff voltage law says that in any closed loop or network, the total voltage around the loop is equal to the sum of voltage drops within the same loop, which is also equal to 0. In other words, the algebraic sum of the voltages within the loop must be equal to 0. This idea by Kirchhoff is known as conservation of energy. Consider the following circuit. The circuit contains a battery. Consider this is the direction which current flowing through this 10 ohm resistor. At this point, current density is more and current density at this point is very less. So consider this point as plus and this point as minus. Name V1 as the voltage drop across this 10 ohm resistor and V2 is voltage drop across this 10 ohm resistor. V4 and V4 is the voltage drop across this 220 ohm resistor. By definition, we need to consider a closed loop. Here there are two closed loops. If there are n number of loops, then we need to find n number of KVL equations. Yes, there are two loops, so we need to find two KVL equation. Now first we consider the first loop. By definition, the total voltage around the loop is equal to, here the total voltage is 5.5 volt, is equal to sum of the voltage drops within the loop. Here first voltage drop is V1, so write it. Now see the signs. Here the signs are alternatives, so put plus. If the signs are similar, then put minus in the equation. Plus V2 is the another voltage drops lie in this first loop. Here it is the first KVL equation. Now we need to find the second KVL equation. Here there is no voltage around this loop, so put 0 is equal to, first we consider the voltage drop V3. Here the signs are opposite, so put plus here, plus V4. See, here the signs are similar, so put minus and voltage drop of this is V2, and this is the second KVL equation.